Hello, everyone. Welcome to the Intro to SQL class. I'm really glad that you're in this course to walk through the language of SQL and learning the building blocks of how it works and how to apply sort of those things into actual practices at work, and also being able to learn and how to manipulate the data really well. I think SQL is really important when it comes to any data related jobs because a lot of companies nowadays still use Excel these days and maybe even like data entry type of data. But those are not scalable. I think those are really small data sets that you just have to manipulate a little bit, or even you just type in the numbers or the data into it to manipulate it to get the results that you want. But you can't do that across million, 2 million, or even, I don't know, billion rows. When you have such a big data set, you do need a SQL, and it's one of the most essential skills that works require these days. And so this is going to be very important. I think everybody, when you even get in an interview, I had some cases where people actually ask you to demonstrate your SQL skills. They will have a sample data and ask you, hey, can you pull this quick data, just any companies that made over 10 million? Give me a list of names that you could get from this SQL Server data that we're giving you. So that kind of system prompts happen a lot. So I'm excited that you're getting into this and learning more about it and also mastering it by the end of this course. All right, so let's jump right in. So our course aims is gonna be four things mainly. The first thing, it's really gonna be understanding SQL and why we need to learn it. And second is familiarize relational database. And third is appreciating the SQL naming conventions that really good to know and good to put to practice. And the last one is knowing how to set up a SQL environment, and that's going to be followed by, and actually we're going to install it together. First, what is SQL? SQL is really a database that brings everything in relationally. What that means is actually when you look at a database like these tables that you see a first table with ID, first name, last name, and there's a phone number element to it, and also department ID. And then there's other tables that follow that don't look exactly like the first one, but it may, you see this sort of similarity in terms of the ID that's coming to place, or maybe budget, maybe location, department name. SQL is really being able to bring all these together. So one of the examples that you can see is, who is the highest paid employee and their top salary. You can actually query it. It's one of the languages that SQL uses, that you can select this and then you can join this and then bring out the result that you want. I think Excel is really specialized in this sense that you can do it. I mean, this is really simple data. You just only have the three tables. You can manually scroll through it, really pinpoint to which one is matching what, budget to ID to amount. But SQL really just helps you connect all these dots together and being able to pull out the data like this clean on the right side. You can have those after going through the querying it, you can simplify into a simple table. So you can have the department name that you want. You can just pull in the top earner name and then top salary. The query might seem like in the middle one, it might be a little bit complicated, but when we start breaking down line by line what those commands actually do and what those actually execute to create at the end, you should be able to really easily understand and perform tasks like this just within a second, maybe 5 seconds or even less when you take a look at it. All right, SQL versus non-SQL. What are some important examples and cases that you have to see is SQL database structure is really all relational, meaning you can all connect them together. So in this case, ID to department ID to employee ID to ID. Although these don't have corresponding column that transcends sort of across the three, connect all in one. That will be really ideal in, I guess, conceptual world where you have the perfect data across the board. But that's not the case across the work environment or work cases that you're going to be working with. But SQL really helps you bring in these data that's connecting with different IDs, sort of key identifiers, and bringing them into one structural piece. What about non-SQL database structure? One of the example I'm going to be using here is, MongoDB, which is in the JSON format. This is what you need to do. Really just identifying objects one by one. And this is really not, everybody likes to say they're visual learners and they're visual people. We like to see something more of a left side where the things are cleaned up nicely in tables that you can read column to rows. But this is kind of like a system language that you have to craft. It's obviously better for the coding side of things that the computer or server processes a little bit better, or maybe or sometimes it's actually worse in terms of the speed, but it's not definitely in a way that it's user friendly that you should be able to read in the data right away. So why SQL? Why do people have to learn SQL if, besides the point of it being visual and relational and you can manipulate data at such a big scale? If you look at sort of the top ranked database languages last year, 2024, and a lot of things, top 4 languages that you see are all SQL related. These may not be completely the same, but it's really coming from the same root. In terms of language, I could say, English and Spanish and all those languages have sort of like a similar root that's in there. It's the kind of same for SQL. That's really coming from the same root. And if you learn one of these, you're going to be able to translate these into different system formats and languages that sort of branches away from SQL pretty well. And this is another thing, really simple that you can glance over quickly, but the database by market size forecast is going to be really big. And this is the area that's not going to be affected by COVID or anything. And we have AI coming up, and it's really being implemented at workspace at such a rapid scale. SQL is only going to grow because AI is not going to feed it. We're not going to feed an Excel, sheet by sheet into AI to really learn from those data. It's going to be mainly SQL and those server side of things that's going to pull it. And then we're going to be able to query that into this AI agent to pull it the exact data. So it's just only going to get more important and only going to be more essential for you to understand and learn going into a workforce. So I've been saying this, the relational database versus spreadsheet. It's kind of explained well in this photo. Relational databases structured in a way that you can sort of combine certain things really nicely, and then they all compartmentalized, and also you can really access things easily and they connect very well. The spreadsheet is just paper. If you have 500 pages of paper that are all sort of in a document format, how do you compartmentalize it? It's just in the wall format. So you have to go through line by line, sheet by sheet to try to figure out where this data is. Does page 1 has data of sales and page 490 has data on IDs and this person's name? You have to manually go through them. So it's a really significant difference between the two. So really, relational database is good at handling large amount of data. This goes large and large and large. And I think, sometimes I've seen a lot of time go to terabyte, but sometimes it does go up to petabyte. It's probably Google or some certain big companies when they handle the data, it probably goes up to that level that you have to query it. But it's SQL, you can do it. It's really easy. It's really streamlined process that you can implement to manipulate the data at such a large scale. And second is when many users need to work on the data at the same time, you can set up, we're going to be explaining these later on. We're going to be showing you when you set up a view or table, which is basically like capturing the language of, by the way, this is a definition of what the view is going to be. This view is only going to show, or this table is only going to show the people that made over $10,000 in the last year. Then, when you set the definition in place and you say the definition for everybody in the server, everybody can access that. They don't need to query it separately. They can just work off of it. They can work on it, and they can also sometimes duplicate it and make it sort of deviated versions of those. Last one is managing data. You can do it in automated systems. So, website and ERP. So some of those things are really just nice to have in a relational database. Spreadsheet, just like I've been saying, it's really for small scale data management. If you want a quick analysis, quick pivot table, quick charts that you just want to pull out, Excel is a great place, or Google Sheet. It's really for, maybe something that needs a quick turnaround. If your boss or someone asks you, hey, can you just pull up a chart of performance among these competitors? And you probably don't want to develop a whole system in SQL that takes like hour or two or longer. You may just want to access quick 20 lines of data in Excel and just chart them out. So that's how you want to have and how you want to use Excel versus SQL when you're given sort of two options.